Hello, Team R. So welcome to Module 3, and we are going to dive in and talk a little bit about running and interpreting a null model in R. And this first video, though, I want to just talk about, try to give you some more tips and tricks around data management, using packages, and just getting more familiar with the R in RStudio environment. So I have up here the week 3 handout, which you can download from the link on Canvas. It'll take you to my RPubs site, and I'll show you how to publish to RPubs if you'd like. It'll take you to my RPub site, and you can actually download an exact copy of this if you want and follow along with me as we talk through this. So, okay, so packages. Let's talk a little bit about packages. This comes up a lot. What are packages? How do they work? So on and so forth. Packages are the lifeblood of R. R is an open source language for statistical computing. And people, volunteers, academics, researchers, computer scientists, data scientists, people of all different types will create packages within R to make R more efficient and do very specific things. Sort of take it from a general coding and stats software package into something very specific. And so you almost always use packages when you use R. And often you use quite a few. So if you look down here, I've got my RStudio open. Of course, you've got files, plots, packages. RStudio has a really nice package manager, which I enjoy quite a bit. It really streamlines keeping track of all your packages. So if you look here, it says user library. These are the packages that do not come with base R. These are packages that I've downloaded and used for different types of analysis. And if you look, I'm still scrolling and I'm only at G. So there are so many packages out there. Still going, still going, still going, that do all kinds of things. Then you get down past the user library, you get to what's called the system library. So these are packages that are installed when you actually download R from the web and you fire it up first time. So a clean install, your very first time, you of course get base R, and I talk about this sometimes, I say base R. Those are the functions that are included in regular R. And then you have all these other tools that come along with it. There also are things, so NLME, for example, is a package for multi-level models. I don't like it as well as LME4, which is the one I use, which is pretty standard. And that is a user-created package that doesn't come built in. But R does have a lot of stuff. You know, there's survival analysis. All that is built into base R. But then there are a ton of packages that can extend their use. And the package manager is the way to do this. And I've mentioned this before. If you ever need to install a package, you just click install and you start typing. So let's say I want to install the package rstan, which is for Bayesian analysis. You click that and then you click install. I think I already have that one installed. So on and so forth. You can do the same thing, and I always like to install dependencies as well, because a lot of packages depend on other packages. It can get pretty complicated. And then of course you can update. You can run updates. So here I need to update a few of mine. A lot of these, you know, it's not essential typically that you update all the time, but periodically, maybe once a month, it's a good idea to come back through and see, you know, a lot of these are very tiny changes, like 1.7.1 to 1.7.2, and you can get news. If you click this, it'll launch the news that's associated with that package, and so on and so forth. So there's actually, I could update a bunch of mine. I haven't updated mine in a while. There are so many packages out there. Now, I love this idea. People have mentioned a little bit in class, keeping a spreadsheet or a Google Doc that keeps track of functions and also keeps track of different packages. I love that idea. I think that's a phenomenal idea. It's a great way to sort of catalog what you've learned so far. A few that I'll throw out there. So the tidyverse for me is essential. It's the first package I load up every time I use R, literally. I sit down, I open up an R chunk and I say library tidyverse, boom, done, fired up. And the reason why is because the packages within the tidyverse are just fundamental to data management, data cleaning, data coding, workflow, data visualization, you name it. So that really is my first go-to, is to fire up that package. And honestly, it's the first place I look when I need a solution. Tidyverse doesn't do any sort of analysis. So it's not going to run regression models. It's going to use other packages like LM, other functions like LM or LME4 to do that. So the tidyverse is purely about sort of functional stuff that you do with data before you actually run your models. But it's incredibly useful, and I use it all the time. LME4 is going to be the multi-level modeling package that we use. It's going to do just about everything that we need in this class. I think with one exception. I think when we get to binary models, we're going to have to switch maybe to NLME to get the nonlinear thing. So the LME4 is linear mixed effects. And so if you're modeling a binary outcome, that's by its nature nonlinear, and so it needs a slightly different approach. This package called Elmer test is very useful. So you use this to determine whether your model has improved statistically by adding predictors. It's kind of like a p-value on steroids type thing. It's very useful. If you're doing anything with labels, I love the HMISC package. I know that seems goofy, HMISC. What does that mean? It's actually named after a person, Frank Harrell, who's a well-known biostatistician who developed a book, Regression Modeling Strategies, super cool book. But he also developed a lot of sort of useful R packages. He's one of the first innovators of sort of developing cool regression packages in R, he and a few other folks. So that package is still very useful. You'll see it down here, HMISC. Some other things about packages. So if you click, I'm down here in the package manager. If you click, for example, HMISC, it will automatically open up the help files for that particular package, the documentation. So this link will take you to a description of what the package is. You can get any news for updates. Sometimes there'll be links to things called vignettes. I highly recommend the vignettes. Those are like worked examples. So LME4 has some vignettes where it'll say, oh, okay, you want to run a 3-level model. Here is an example of a 3-level model that we've worked out that you can kind of follow. This is a really common way of learning in R, is taking a package, maybe you hear about it, I'll talk about that in a minute, or maybe other people are using it. You grab it, you look at the documentation, and you read the vignettes and see what's going on. So what the documentation contain here, these are all the functions. So all a package is a group of functions. We can develop our own functions in R as well. We won't do too much of our own function development in R. That's kind of its own thing. But they're just tiny little programs that are built in that allow you to do different things in the R language. And so here, each one of these, absolute error prediction, add marginal, all dot digits, all is numeric, so on and so forth. These are all functions that are found in the HMISC package. Some of them you use all the time, some of them you never use. It just kind of depends. Some of them run in the background. And the key is not like, I'm going to take this package and learn every function. It's the functions are listed there when you need them, and you can sort of take a peek and see how they work. And we'll talk about that in just a second. Okay, so that's a little bit of a background on packages. If you want to know more, I highly recommend subscribing to a listserv, a daily email digest called r-bloggers. And I believe it's r-bloggers, like the actual dash, not the word, r-bloggers.com, I think is the website. So this is a website where anyone who works in R and posts a blog about working in R typically will send their post to this website that collects all the stuff that's going on. And it is amazing. You cannot believe this kinds of things that people are doing in R. And what's cool is once a day you get a digest of all those postings, and you can just skim it and see if anything looks interesting. And if it doesn't look interesting, don't have to worry about it. But if you see something cool, like, oh, wow, someone's doing cluster analysis or multi-level modeling, you can just click the link. And typically what people do, particularly if they're using R, they'll give you the code, they'll show you the data, they'll walk you through it. So there's a lot of learning that can take place just from sort of being aware of what's going on and trying to stay apprised of that, which is really, really good. There also are, so RStudio does monthly package roundups. So those get posted on the R bloggers email list where they just walk through all the new packages that were developed and posted to CRAN, which is the CRAN, which is the sort of consortium that manages R and keeps all the packages and things. And so that's another good way to stay apprised of things. Okay, I'm rambling. Sorry, but that's just a little bit of information. And I will always try and tell you, you know, packages, what they are, and so on and so forth. A real quick and easy thing, if you, you know, sometimes I have at the beginning, I always put at the beginning of my statements, library, and then in parentheses, the name of a package. You can always tell if you call a package, for example, that doesn't exist, you will get an error down here in R. And that's very, very common. It'll say like no such package exists, or there is no such package called such and such. And then to fix that, you just go to the package manager and you just install it. That's all it is. So it's not a big deal. That's just kind of how R works. It's a little clunky. So if you don't have the right package, you have to go and get it, but it's not a big deal at all. Okay, so now I'm going to get back into this specific example, and I'm going to start by loading packages. So I've talked to you about what these are. Now here's a little trick. A typical code chunk looks like this, where you have 3 backticks and then in brackets, the little letter R, and that's sort of telling R that this is our code that we're going to dump in here. So if you put a comma there, you can add a few options. You can sort of customize that chunk. And one of the things that kind of drives me crazy, I don't like when I open the tidyverse, I get like a whole page of responses, because the tidyverse is actually like 7 or 8 specific packages, and you get all these warnings and, you know, this function is replacing this one and so on and so forth. And so I just put print equals false right here, just on the package call. I don't put it on any of the other ones because I actually want to see what comes out. But when you say print equals false, R will not print the result. It'll just load the packages, which I actually really like. So when I run this, you see it turned green and my packages are loaded, but there's no other sort of additional information. You might get a few lines if you haven't opened these packages before, but that's about it. All right, so we're going to load in the data. And so I have already pointed my computer at where the data are. So the data are in a CSV file. We talked about those last week, a comma separated variable file. And I have pointed my computer to week 3, which is where I store my data. And I have already chosen set as working directory. So that's already done. And I can actually see down here at the bottom, this is my working directory. And so my computer is already oriented towards week 3. So having done that, I can load in my data without including a lengthy file path, which is really nice. The data are called hsbmerged.csv. So the call is just read_CSV. And then and I believe that's the readr package, which is included in the tidyverse. So that's already loaded up. We're good to go. And then in quotes, hsbmerged.csv. And then I typically like to follow that up with a glimpse of this data set, which again is high school and beyond, the big longitudinal data set. I like to glimpse to get a summary of this. So I'll run that. And we get this particular set of information. First of all, we get some information parsed with column specification. So it's telling you, okay, I was able to go in and grab this CSV file, and this is what I think all these variables are. So it's sort of looking at all the variables and trying to give them a specification. Is it characters? Is it a number? Is it true, false? What's going on here? So for all of these, R is just saying, I think these are just numbers of some kind. That's what column double means, which is fine. We can work with that later. And then here is our glimpse. And again, another very handy call that I like very much. So 7,000 rows, those are the number of people. 11 columns, those are the number of variables. We have a school ID. We have a measure of minority, female, SES, math achievement, size, sector, I think that's something about like practical academic, disciplinary climate, high minority, mean SES. Okay, so we're not going to use all these right now, but just to walk through a few of these. So school ID, that's just an identification code for what school each person is nested in. Minority status, this is a measure of whether or not the student identifies as a racial or ethnic minority. This data were collected in 1982. So from a QuantCrypt perspective, you know, of course, this is not a good way of thinking about racial or ethnic difference or identity, of course. But it's kind of what we have in this data set. And so we'll have to sort of work with it the best we can. Female, here it's just only two options. Again, not ideal, female and male. That's what we had in 1982. SES, in this case, you'll notice it's interesting. SES appears to be maybe continuous. And sometimes you can have scales, SES scales, where you ask people a number of questions about, you know, how many books do you have in the house, or how much education parents have, so on and so forth. And you can kind of create an SES composite based on that, which just seems to be what they've done here. Math achievement, size is a measure of school size. So school up here, school 1224, has a size of 842. Sector, we'll talk about that in a minute. That's parochial, which is like private religious, I think, and then public. So it's interesting, this data set was collected at a time in the 70s and 80s when there was a huge educational debate, believe it or not, about private schools, about the contributions of private schools and private religious schools. And so this data set actually oversampled parochial schools, private religious schools. You'll see it's pretty much even between public and parochial, because that was the particular research question at the time. What is the impact or contribution of a private or parochial school? And so that's kind of interesting. So sector, I'm not sure what these two are. High minority is like a dummy variable indicating whether or not the school is majority students who identify as racial or ethnic minority. So it's kind of like majority minority in a way, a school that's more diverse. Again, not a great measure, but for 1982, it was okay. And then mean SES is the average SES score at the school. So taking all the kids who were surveyed in the school, take the average of that. And what was that? So I believe SES is centered on 0. So 0 is someone with average SES. So 0, you know, would be a school with mean SES roughly as well too. Okay. So, all right. So now a few more quick cleaning and coding tips. I recommend the summary command from base R. I think it's really nice and easy as a quick way to get your feet or get your head around the a particular data set. So when you run summary and then HSB, which is the name of our particular data set that we've entered in here, our data frame, we get a set of quick summaries about each variable. Now, keep in mind, R thinks these are all doubles. These are all numeric variables. So it's going to give you a numeric summary. You know, it doesn't know, for example, that female or minority are actually measures of categorical variables. It's just assuming that everything is a number. But for something like math achievement, you know, it's pretty useful. The min is -2, the max is about 25, the mean is 12.75. For size, the smallest school was 100, the largest was 2,700, the average school was right around 1,000. So that gives you a sense of the high schools that we're looking at. Mean SES here, yep, was right around 0. SES itself is right around 0. It goes from -4 to +3 roughly. If a variable is binary, which in the case like female, we know it is, that's how it was measured in this case. So 0.52, so female is equal to 1, male is equal to 0. In that case, that means that 52% of your sample is female, 48% is male. And then sector, 0.49. That means that 0.49 or 49% of the schools are sector equal to 1, which is actually parochial, and the remaining 51% are public, and that's sector equal to 0. And that just comes from the code book. And if you look on page 482 of the Garson text, Garson goes into a little more detail about this as well. He sort of walks through the code book for the HSB data set, which is a very, very well-known one. Okay, so all right, so that is the data set. We have it loaded in. And so now let's give some of these variables a label. So if we look at HSB right now, we don't have any descriptive labels here. All we have are the names of the variables. And so let's give some of these variables a descriptive label. So the command for that is label, and that comes from the hmisc package. It's already been loaded in, so you don't need to worry about it. It's already going. And so you just type label, and then here I'm using the $sign to index a specific variable. So I want you to label HSB math achievement equal to, and then in quotes, standardized math score. So run that. Same thing, label the sector variable school sector, like that. So now they should have labels. You can double check it by running the str function, and that is short for structure. So anytime you run str, you're basically saying, I want you to open up this thing and tell me what the composite parts are. So when you ask for the structure of a variable, you get lots of things. So first of all, it's telling you that this variable has a label. The label is school sector. It is numeric. And here are the first 10 examples, and they're all 0. So it sort of gives you, structure can be nice. What you're looking for here is it has the label actually been included. Another thing you do is you can go back to your HSB data set. Actually, I think I need to reload it. Let me reopen it. Yeah, and so now you can see there's a little label below here, which is awesome. So now math achievement, standardized math score, sector, school sector. So the labels will affix themselves to the data set in R, which is really nice. And I highly recommend doing that. Okay, so that is a demonstration of how to create a descriptive label for an entire variable. Now I want to show you how to do some other stuff, including how to code individual values within a variable. So an example here might be this variable sector. I happen to know, because I've read this Garson book too many times and worked with this data set too much, that parochial is equal to 1 and public is equal to 0. But most people don't know that, and they shouldn't, to be honest. So it would be useful if I could hard code in R that 0 means public and 1 means parochial. And so I'm going to show you how to do that. The first step to doing that is to create some factor variables, because you can't affix variable labels to numeric values, to something that R thinks is just a number. You need to affix them to categorical variables, or factors. So you first have to create factor variables. And so to do this, I'm using the similar pattern that we learned about last week, which is to create a whole new data set called hsb.clean. Again, I highly recommend that you do not touch the original data once it has been entered into R. It is so useful to have an original copy of your data to go back to at all times. And so I generally will always create a data set, give it a name, and then create another data set .clean. And that's the one I run my models on, and so on and so forth. So this new data set is going to be called hsb.clean, and it is going to be defined first starting by hsb, which is my existing data set. And then, so there's that pipe operator. So first start with hsb, then our friend mutate, which is a very useful way of creating new variables based on existing ones. So I want to mutate, and I want to create a new variable called sector.factor, which is equal to the original variable sector that has been turned into a factor using the command or the function as underscore factor. Okay, and then a comma. And then I'm going to do the same thing with female and the same thing with minority. So what I've done here is I've taken 3 variables that should have been categorical to begin with, and I'm making new variables that actually are categorical and are defined as factors in R. So I can run that, just that chunk, and Control Enter will run just the current line or the current string of code. So now when I look up here, I have a new data set called HSB clean. And when I open it, sure enough, I have my original variables. And then at the end here, I have sector.factor, female.factor, and minority.factor. So those are now categorical variables, which is great. That's what they should be. Now that they are categorical variables, I can actually attach summaries to them, or not summaries, sorry, levels to them. I can start to code individual levels. And so the command for that is levels. So you say levels, and in parentheses, you define which variable you want to define your levels for. So the levels, I'm in the HSB clean data set, sector.factor. Those levels are equal to public and parochial. Now, a little bit to say about this. This is probably the first time that we've actually seen a character vector. That's what this is. So C, a vector is just a string of values, a one-dimensional string. So it could be numbers, it could be letters, it could be words, and they're separated by commas. So again, R is a programming language, so it kind of likes these ideas of vectors and matrices and things like that. So for our purposes, we just have to keep track. The labels, the levels, the number of levels has to match the number of values. And sector has 2 values, 0 and 1. And I just need to define my levels in that same order. So the lowest numeric value goes first, and then it increases sort of as though it were sorted from smallest to largest. So I have 2 values, 0 is public, 1 is parochial. If I had a private that was coded as 2, then I would add it on here. I would just do comma and then private, like so. But I don't have that, so I'm gonna take that out. Okay, same thing here. Levels of this female factor variable are equal to a character vector. Male is 0, because it's a dummy variable, so female is equal to 1, male is 0. So male is 0, female's 1, and it always goes from smallest to largest, left to right, okay? And then here, this minority factor, 0 is non-minority, 1 is minority, okay? And again, so the nice part about this, this is flexible to much more inclusive measures of all this stuff, right? So if you had 4 or 5 categories for gender identity, no problem. You can just add categories. You can add categories for racial or ethnic identity. So you're not limited to these binary distinctions. It's just these are what we have in the data. And so that's what we're coding. Okay, and so you want to run those. You can run them separately or all at once. And now those values have been attached to those particular variables. And again, we can use the structure command. And now when we look at sector, so remember up above, we looked at sector and it said, okay, here are the first 10 values, but there are no labels. So here we have public and parochial. So now we actually have values here, which is very, very useful. And then when we go look at our data, look at how this has changed. So now, participant number 1 identifies as female. For female factor, we actually have the word female, which is useful. And, for sector 0, we now have public. So R is fully aware of the categories and the categorical variables, which is really great. Okay, so you can actually set up a nice set of code here to clean and code any kind of data and attach different levels without any issues. Okay, and then once again, if we run the table function, I think we ran this last week. So all table does is it takes a variable and it splits it up into different categories. It's like crosstabs, or frequencies, asking for crosstabs or frequencies. Now, when we run the table function, it actually attaches those labels to the table, which is really nice. So public, we have 3,642 students who are in public school. We have 3,543 students who are in parochial school, okay? Another cool thing, if we rerun this summary command on our hsb.clean data set, you'll notice that we actually get counts for our categorical variables instead of quantitative measures like mean, median, so on and so forth. So R automatically knows, okay, this is a factor. You just want the counts. You don't actually want the mean of a categorical variable. So now we have our counts in here, which is pretty cool too. Okay, just a couple other things, and then we're going to run our ICC. So a few other things that I like to do. I really like running some sort of a numerical summary of my outcome. So in this case, we're going to look at math achievement. And math achievement, again, is in the hsb.clean, data set that I've created. And here I'm going to use the describe function. And actually, I should change this. This is not actually in the psych package. This is actually in the HMISC package. So here I'm not using psych at all. Psych is great and produces a nice description, but this is all, it eliminates having to load in another package if you don't have to. So if you run describe, you get a nice descriptive summary. So the mean is 12.5, 12.75. I forget what GMD is, greatest mean deviation, maybe? I can't remember. And then you get your percentiles. So the smallest value, or the 5th percentile to the 95th, and then you get the 5 lowest values and the 5 highest values. So that's, again, another nice summary. I also like that you get a summary of missingness, so how many are missing, and you also get a measure of how many distinct values. That's very useful as well, trying to understand what's in an actual data set. And so then, I can get rid of this. This is just a little residual code here. I also like to do a good histogram. We learned how to do this last week or 2 weeks ago, I think. I'm going to show you how to clean up this histogram even more. So the command here is hist. So HSB clean $ math achievement. To give it a title, the command is main, and then you put the title in quotes. Sub is the subtitle, and that typically goes directly below the title. And then xlab gives you a label for your x-axis. And again, you put that in quotes. You can change all that around. And the goal here is not to produce the most beautiful plot ever. It's to produce a functional plot so that you can see the distribution of the scores. The title is nice though, you know, kind of if you need to drop this in a report or something, it's a nice way to break this up. So there's a nice frequency of our math achievement variable, and it does look pretty normally distributed. Okay, so all right, just to recap for a moment, we started off this video by talking about packages, what they are, how they work, which ones you need, and how to find out about them. So kind of put that out there. Then we used the read CSV function to load in a comma-separated variable file with our HSB data. And then we learned about the summary function, which gives you a nice quick and dirty summary of all the variables. And we decided we needed to create some labels. So we added descriptive labels for a few variables. And then we used mutate to create some factor variables and give those factor variables specific levels. So actually attach words to the numeric values. And then we took another look at our summary and described and visualized our outcome. So these are all very sort of typical standard tasks that you would do when you're doing an analysis, you know, getting the data in, cleaning it, getting it in the right shape, and then and looking at histograms. Coming up, I'll show you how to run a null model and how to interpret it, and then we'll be all set for Module 3.